Welcome to AI Chain Reaction, the podcast where we unpack the incredible world of artificial intelligence and automation. Each week, we're diving deep into the tech that's reshaping our lives, our businesses, and our future. From groundbreaking innovations and the latest industry news to practical strategies on how you can leverage AI automation for growth. We're covering it all. We'll be joined by leading experts, innovators, and thought leaders who are at the forefront of this digital revolution. Are you ready to explore how one small change can set off a massive chain reaction of progress? Then you're in the right place. Let's get started.
Welcome back to AI Chain Reaction, where we explore how small and mid-sized logistics providers can supercharge their operations with AI-powered tools. In episodes 1 through 4, we explored how AI agents can extract shipment data, generate alerts, and automate notifications. Today, we tackle scaling, how a small or mid-sized shipper can grow from a single AI-powered tracking lane into a fully dashboarded, company-wide system. We'll cover everything from clean data integration and modular design to team adoption and ROI metrics. Jordan, are you ready to dive in?
Yeah, absolutely. Scaling is where things get real. We've seen those single route pilots work great, but expanding to dozens or hundreds of shipments brings new challenges. Now, it's about building a robust foundation. Today, we'll mix practical tips with real examples to make things easy to grasp. No PhD required.
Let's walk through a hypothetical scenario. Imagine Acme Logistics, a 3PL with just one shipment route tracked by an AI agent. They want to scale up hundreds of shipments across multiple carriers. Step 1 is data preparation. We need a unified data schema. Instead of handling each carrier's raw data format separately, we define a standard shipment record format that includes status, location, timestamps, etc. This way, every new route or carrier just plugs into the same schema.
Right. And that mirrors a real case study where a startup built a cloud-based shipping platform. So they integrated multiple carriers and used a scalable cloud infrastructure so the system could handle growing users and shipments seamlessly. In practice, this means using a database like Postgres, Snowflake, or Superbase that can auto-scale and store data in a consistent format. And once data is standardized, we build an ingestion module that pulls in each lane's updates. Then a separate processing module cleans and transforms that data. Again, for example, calculating ETA or risk scores, like a dashboard or report. Each component is a module or microservice. If ACME wants to build or add a new service, say ocean freight tracking, later they simply plug in another ingestion module and point it at the same processing dashboard pipeline.
To illustrate, one logistics platform made their user interface super easy so non-technical staff could adopt it without heavy training. They also built on a cloud backend that automatically scaled with demand. Our ACME scenario should do the same. Start small, then spin up more processing instances or database capacity as shipments grow. And the key steps in our scenario are standardized data. Define clear data fields like status, ETAs, location, etc., so new routes fit easily. Next, we have separate functions. Keep data collection, AI processing, and dashboards separate. For instance, since LLM agent like LangChain to parse emails or docs, a Python function for ETA, and a DB API for storage. And lastly, API first design. Expose each function via REST and GraphQL APIs so other teams or tools can use them. This makes the system extensible. For example, a retail shipping partner using an AI tracking system saw 35% fewer missed deliveries and 20% faster resolution on exceptions. In our conversation, that success came from automating alerts and centralizing data so everyone had up-to-the-minute info. As ACME scales up, they'll push these alerts through the new channels like SMS, email, and dashboards, using the same core agent logic.
Let's break down our strategy bullets, building on that scenario. To start off, clean data integration. We're going to want to start by mapping carrier data into a master format. Use ETL tools or scripts to cleanse incoming data. One study found that logistics companies spend about 60 to 70% of their AI budget just on data prep and integration. So investing here pays off. And then we're going to want to enforce data governance, use unique shipment IDs or consistent timestamps. So machine learning models and dashboards stay accurate. Second, modular API-based architecture. Design each piece as a service. For instance, use a LangChain agent that understands your data needs so it can query database or call APIs on demand. By breaking tasks into steps, for example, fetch data, compute ETA, log results, the system mimics human problem solving and is easier to maintain as well. Each module, carrier connector, alert engine, dashboards, talks over APIs. This lets you reuse components and avoid a monolithic code base. Following that, we're going to have cloud and containers. So here we run modules on cloud servers or containers so you can scale them separately. In the Superbase case study, Maergo trimmed their code base by 90% and scaled to 100x their normal traffic during peak season. They used a managed Postgres, Superbase, with edge functions. A similar principle applies. Cloud-based services like Azure Functions or AWS Lambda can auto-scale your data ingestion and processing tasks as shipments surge. Next, we have no-code, low-code tools. Consider tools like Retool to quickly build dashboards and admin interfaces. Retool's platform lets you quickly build custom internal tools and dashboards with both pre-made and custom components and minimal coding. This means ACME's ops team could drag and drop tables and charts rather than write a front-end from scratch tool. Retool connects to databases, APIs, etc. So it's just another piece of our API ecosystem. And then finally, we have orchestration with AI agents. Frameworks like LangChain or AutoGen can be game changers here. They let us program agents that let us act autonomously. For example, an agent could fetch the latest GPS or EDI update, run an ETA tool, and then push an update to the dashboard. Importantly, LangChain can connect to many data sources, databases, APIs, documents, even emails, all in one workflow. This ensures your AI can pull anywhere without needing custom code for each data type. Now, following that, let's name drop some tools and how they fit. To start off, we have LangChain and LLM orchestration. LangChain helps us build AI agents that string together actions. For instance, a LangChain agent could query your Superbase or Postgres DB for late shipments, ask Azure OpenAI to draft an email update, and then call a Slack API to send it, all in one flow. It breaks tasks into steps, handles context, and mimics human problem solving for complex workflows. Following that, another example is Superbase, a scalable database. Superbase is a managed Postgres with built-in APIs and auth. Now, in the Maergo case, they migrated from a huge MongoDB codebase to Superbase and saw their code shrink from CK to 1,000 lines and scale 100x without issues. Small logistics companies can use Superbase tables to store shipments, events, and user data, and rely on its real-time features and even edge functions to process data at scale. Following that, we have Azure OpenAI service. This cloud offering lets you host models like GPT-4 or Claude. For logistics, you might use it for NLP, such as reading carrier emails, summarizing reports, or for semantic search over documentation. For example, C.H. Robinson used Azure OpenAI and their Foundry system to streamline freight booking, predicting freight terms and automating paperwork. The point is the cloud AI services remove the need for you to host your own LLM servers. Another example is Snowflake, a data warehouse. Snowflake can centralize all your logistics data, TMS reports, lot tags, customer queries in one place and run analytics or ML. Integration services like HTO AI's APIs can plug into Snowflake for forecasting or anomaly direct detection. While Snowflake is often for larger firms, however, small shippers might use it for historical analysis as they grow, feeding clean data from Superbase or their TMS into Snowflake for heavy queries. The next tool is Retool for dashboards and tools. As mentioned, Retool lets engineers quickly make dashboards and admin UIs. For instance, build a shipment overview dashboard in minutes by connecting Retool to your database or your API and dragging in tables and filters. This is much faster than hand coding a front end. Retool lowers the barriers so that even operations or support staff can update or extend tools without a dev team. Finally, we have Zapier automation platform for lightweight integration. Zapier can connect thousands of apps. A great example is Virgin Logistics. They use Zapier plus AI to automate contract onboarding. Whenever new contract PDF landed in Google Drive, Zapier extracted pricing into a data sheet and then pushed it to their system. The results? Hours saved, billing accuracy up, and scalable onboarding with no new hires. Similarly, an SMB could use Zapier to say, trigger Slack alerts to copy data between web apps as shipments update. Now, all these tech improvements need people on board. A key lesson, invest in training and communication. DocShipper reports that companies allocating just 15% of their AI budget to training and change management saw X higher adoption and 3x higher ROI. In concrete terms, this means setting aside time to show every department, ops, customer service, sales, how the new tracking dashboards or alerts benefit them. Now, we're going to start off with champion users. What this means is have one person from each team, whether it be warehouse, customer support, sales, to be an early adopter. Let them play with the system and give feedback. This bottoms up approach ties in with the research. When operations experts work alongside, each team's implementation succeeds 65% more often than when IT goes solo. And then we want to communicate value. Show metrics or stories. For example, if the system predicted and avoided a delivery delay last week, highlight that success. Since many small firms worry if AI is worth it, sharing wins gets people excited instead of fearful. Finally, we have iterative rollout. You're going to want to start by expanding one function at a time. We had tracking alerts for inventory, next add predictive ETAs, then automated reporting. Each wave brings more data and experience. After each rollout, update teams on results and refining training. Now, to manage resistance, emphasize that AI assists staff rather than replaces them. For instance, automation can handle repetitive status check tasks, leaving humans to focus on exceptions and strategy. Overcoming the fear of technology is easier if people see AI taking mundane work, like data entry, off of their plates.
Now, pitfalls to watch out for and how to monitor as you grow. Data silos and quality. One big trap is fragmented data. If carrier info lives in emails, spreadsheets, and legacy TMS separately, your AI won't have the full picture. Statistics show that average logistics firm uses only 23% of its data for AI. The rest sits locked away. Fix this by consolidating data sources, for example, ingest all TMS exports into your new database. Also, clean up duplicates and formats. In fact, 76% of supply chain orgs report master data issues like duplicate records that undermine AI accuracy. Proactively catch these. Run nightly checks for missing fields or mismatched IDs. Underestimating costs. Enterprises spend hundreds of thousands on AI systems, and 62% of projects go 45% over budget due to unexpected data work. For an SMB, start small. Use cloud models or pre-built tools to avoid big upfront hardware costs. There are budget-friendly options, even free tiers for Supabase, Snowflake trial credits, etc. Always track spend versus value as you scale. Early budget overruns often come from data integration. This emphasizes the need to plan data work first. Workforce resistance. As we saw, most project failures trace back to people, not tech. Deloitte found 72% of failed logistics AI projects cited employee resistance as the cause. Combat this by keeping teams involved and informed. Don't spring a new system without warning. Instead, explain, this tool will automate X, freeing you to do more Y. Provide support documentation or quick help chatbots for new users. Monitoring for scale. Once running, measure system health and business impact. At a technical level, use monitoring tools like Grafana, Datadog, or built-in database dashboards to watch API latency, error rates, queue lengths, and database size. For example, alert if batch jobs start taking too long or if your deployment can't handle new requests. On the business side, track metrics like shipments processed per hour or alerts sent per day and watch trends. If processing time spikes or support tickets about the system increase, it's a sign you need to optimize or add resources. Pitfall alert. Be mindful of AI bias or privacy. If your tracking AI starts consistently mislabeling a certain route's delay reasons, have a human check the logic. And ensure you're compliant with data laws like GDPR, etc., especially if tracking international shipments. Looking ahead, a few trends will transform scaling. Predictive tracking and analytics. Beyond reactive alerts, systems are getting more predictive. AI models can forecast delays before they happen by analyzing weather, traffic, or port congestion. In fact, experts say AI in logistics is reshaping supply chains with predictive AI in logistics is reshaping supply chains with predictive analytics, autonomous fleets, and digital twins. That means your tracking system might soon recommend preemptive reroutes or relay risks. That means your tracking system might soon recommend preemptive reroutes or relay risk scores for incoming shipments before your team even asks. Autonomous and robotics. We're seeing drones, self-driving trucks, and robotic warehouses. While fully autonomous fleets are still emerging, it pays to design your tracking system to accept data from these sources. If a truck reports its own telemetry, feed that into the AI agent. Digital twin models like virtual simulations of your network are also on the rise. helping you test new routes or capacity changes in software before risking real shipments. API ecosystems and integrations. More carriers and platforms now offer open APIs. For example, Flexport provides shipment tracking and customs APIs for end-to-end visibility. And many supply chain tools offer data APIs to pull in forecasts or rates. Building on a strong API architecture means you can plug into an ecosystem. Today's trending buzzword, API ecosystem, is not just hype. It's about having a network of interconnected services. So design your system so that adding a new partner's API or predictive analytics API is straightforward. Fun fact, one list of top supply chain APIs highlights everything from predictive forecasting to carbon tracking as swappable services. Conversational AI, stational AI, and agents. As we talked about generative models, expect more chat-like interfaces for ops. Imagine asking an internal chatbot, which of my shipments are behind schedule, and getting an instant answer from the agent that just queried the dashboard data. This turns staff into fluent consumers of the tracking data without needing to log into a full BI tool.
Right. Finally, let's nail down metrics to measure ROI on scaling. Start off, we have labor hours saved. Track how many hours your team previously spent on manual status checks or rekeying data versus now. Reports suggest measuring hours saved per week is key here. For example, Virgin Logistics freed up hours of contract work with Zapier. We saw automation shave off the manual intake entirely. Apply the same lens to tracking. Measure customer support calls with shipments before versus after. Next, we have cycle time. How much faster are shipments updated end to end? If shipments used to be nightly and now are real time, similarly, if your mean time to alert for a delay drops from, say, 4 hours to 10 minutes, quantify it. Next, we have error and ticket reduction. Count support tickets or corrections related to shipment status. AI and automation often reduce errors by avoiding manual, retyping, or misreads. One ROI guide noted percentage of tasks auto-resolved and errors eliminated as core indicators. If your system auto-populates 90% of status fields, you should see a corresponding drop in support requests. Following that, we have throughput and capacity. Measure how many shipments can be tracked per staff hour before versus after. If one employee managed 50 shipments a day manually, but now with AI agents, that same person handles 300 because the system does the heavy lifting, that productivity gain is a great ROI story. Finally, we have service level or on-time performance. On-time delivery rate and average delay can be tied to customer satisfaction. If AI tracking and alerts reduce late shipments by noticeable percentages, like 33%, that translates to customer retention or reduced penalties. Now, Now, it's useful to keep a dashboard of these KPIs, regularly share them. We've saved X hours this quarter, Y fewer tickets, and improved on-time rates by X percent, and improved on-time rate by X percent thanks to our AI system. Seeing the numbers builds the momentum for further investment.
To wrap up, here are our key takeaways. Start with clean data and modularity. A strong, scalable foundation is half the battle. Use API-based, cloud-native design so you can plug in more routes or features without rewriting everything. Leverage the right tools. Frameworks like LangChain let you flexibly create AI agents across data silos, while platforms like Supabase and Retool accelerate development. Zapier and cloud AI services fill in the gaps with minimal coding. Invest in people. Don't ignore training and change management. They are proven multipliers of ROI. Engage your teams early and celebrate wins, like the logistics partner who saw 33% fewer missed deliveries. Measure results. Track hours saved, faster updates, and reduced errors. Seeing tangible improvements keeps stakeholders on board and guides future scaling efforts. Future-proof with innovation. Keep an eye on predictive analytics and autonomous logistics trends. An extensible system today can embrace those advances tomorrow.
And remember, scaling is an ongoing process. Start small, automate the low-hanging fruit, then iterate outward. Before you know it, that one-lane AI tracker has become an integrated command center. We hope these insights help any small or mid-sized logistics team take their AI tracking to the next level. Share your own success stories or questions with us.
That's it for part 5. If you've enjoyed this, subscribe and stay tuned for part 6. Meanwhile, check our show notes for the links and resources mentioned today. Thanks for listening and keep moving those shipments smartly.
And that brings us to the end of another episode of AI Chain Reaction. Thank you so much for tuning in and exploring the incredible world of AI and automation with us. We hope today's discussion sparked some new ideas and gave you valuable insights into how these technologies are shaping our future. Don't let the conversation stop here. What was your biggest takeaway from this episode? Let us know in the comments below. We love hearing from you. If you enjoyed this deep dive, make sure to hit that subscribe button and turn on notifications so you never miss an episode. For more resources and to learn how AI automation can transform your business, visit us at wintersAIsolutions.com. Thanks again for being part of our community. Until next time, keep innovating and stay curious.